In 2.1, we're going to go over average and instantaneous rate of change, which we also did last chapter. Okay, so some things to recall about rate of change. The first thing, if you're finding the slope, you're finding the change in y over the change in x, or sometimes you learn the formula as y2 minus y1 over x2 minus x1. Okay, so if you're trying to find the average rate of change of f of x over the interval a, b, including a and b, where a and b are the x values, it's going to be the y value minus the y value. So at b, the y value is going to be f of b. At a, the y value is f of a. And I'm going to do b minus a, because that's the same as y2 minus y1 over x2 minus x1. So for example, 1, it says find the average rate of change of f of x equals ln of 3x over the interval 1 is less than or equal to x is less than or equal to 4. Rate of change, average rate of change, they just want the slope. So I'm going to use the same formula, and I'm going to abbreviate average rate of change with AROC. Okay, so if I want the rate of change from 1 to 4, I'm going to do f of 4 minus f of 1 over 4 minus 1. What is the f function? F of x equals ln of 3x. So I'm going to go ahead and plug in 4 for x. So what am I going to have? I'm going to have ln 12, natural log of 12. And then if I substitute in 1 here, I have the natural log of 3 over 3. This is kind of an exact answer, but then if I substitute it into my calculator, I can get an approximate answer. Okay, if I put that in my calculator, I get approximately 0.4621, and I'm going to keep 4 decimal places for now. Okay, now how about if you want to find the average rate of change from a table? So I'm going to find the average rate of change on the interval 2 to 30, including 2 and 30. I'm going to do it the same way we did it on the previous problem. The average rate of change from 2 to 30 is going to be f of 30 minus f of 2 over 30 minus 2, and I'm going to use the table to get my values. So f of 30, when the x is 30, the y value is 7. So that's 7 minus f of 2. When the x is 2, the y value is negative 2 over 28, which is going to be 9 over 28. So the average rate of change from 2 to 30 for the function indicated in the table is 9 over 28. Okay, now we're going to consider average rate of change versus instantaneous rate of change when I'm looking at a graph. Okay, the average rate of change over the interval a comma a plus h, including the endpoints, would be, let's see, f of a plus h minus f of a over a plus h minus a. Or if I said that the interval was going from a to x, it would be f of x minus f of a over x minus a. Okay, our average rate of change is the same as when we did the slope of the secant line. So if I drew, okay, don't copy this part. Okay, this is my little line. If I want to find the secant or the slope average rate of change from here to here, I would draw the secant line, and then I would find from here to here what the slope of this secant line is. So this is representing average rate of change is always a secant line. Secant line, remember, it goes through 2 points. Okay, now when we want the instantaneous rate of change, when we were estimating it in the previous chapter, we were looking at the tangent line because the instantaneous rate of change happens at only 1 point. Okay, so this is the formula for the instantaneous rate of change, and then we'll look at it and see why it's actually the same as what we were doing last chapter. Okay, the instantaneous rate of change, or IROC, is the limit as h approaches 0 of the average rate of change. The reason it's like that is because if you recall last chapter when we wanted to find an estimate for the instantaneous rate of change, if we wanted the rate of change at x equals 3, we might do it from 3 to 2.999 or 3 to 3.001. We picked 2 points that were as close together as possible. So in this case, they're saying at point A, I want to pick another point that's really, really, really close to it. So I do A plus H. If H is approaching 0, then H is like so tiny, it's practically equal to A. But it's far enough away that I can find the slope of it without it being indeterminate. So as H approaches 0, these are 2 points that are super, super close together. The reason it's an H at the bottom is because if I do A plus H minus A, the A's cancel out. Okay, if I use this ratio to find the instantaneous rate of change, it's the same idea. I'm going from A to X, but I really just wanted it at one point. So I knew these 2 points to be basically at the same point. So they're saying as X approaches A, I want to find the slope. So this is f of A minus f of A, but it can't really be f of A minus f of A because it'll be indeterminate. So we're trying to get as close as possible, infinitely close, but not so close that it becomes indeterminate. And on a graph, this is representing the slope of the tangent line because a tangent line hits only one point on the graph. Okay, both of those formulas can be used to find the instantaneous rate of change, and they will give you the same result. Sometimes it'll tell you which one to use. Sometimes you can find it on your own. Okay, so I'm going to find the instantaneous range of this function at x equals 4. And if you remember, rate of change is the same as slope, so it's actually finding the slope of this graph exactly at x equals 4 if I drew the tangent line there. Okay, so for part A, we're going to use this formula to evaluate the instantaneous rate of change. Okay, so let's go ahead and plug it in using this formula, and then we'll try it the other way to make sure we actually do get the same answer. So this is the limit as h approaches 0. Okay, what am I trying to find it? I'm trying to find it at x equals 4, actually. So where the x is, I'm going to replace it with 4. So this is going to be f of 4 plus h minus f of 4. And then the whole thing over h. And I remember I picked the 4 because they told me to find it at x equals 4. Okay, I'm going to go ahead and plug this in. Okay, so f of 4 plus h, they want me to take this 4 plus h expression, plug it in the f function where the x values are, here and here. So that's going to be 4 plus h minus 4 plus h squared. Okay, and then they want me to subtract the value of f of 4. What is f of 4? F of 4 is going to be, I'm going to put it in parentheses, 4 minus 4 squared, which is 16. And then the entire expression is over h. Okay, let me go ahead and simplify this. Okay, I'm going to distribute this. 16 plus 8h plus h squared minus negative 12, so plus 12 over h. Okay, and then let me go ahead and keep simplifying it. What am I doing? I'm subtracting, so remember to bring your minus sign in there. Should I change it? Maybe I'll change it. All right, let's see. I'm going to make this positive, so negative, negative, negative. Okay, so I have 4 minus 16, negative 12, plus 12. Those all cancel out. Let me go to the h terms. I have h minus 8h, so that's negative 7h. And then what else do I have? And then I also have this negative h squared. And then the entire expression is over h. Okay, I'm going to go ahead and simplify this. I'm going to take out the negative and the h. Okay, now I can cancel out these little h's here. Negative, and then I have a 7 plus h. Okay, I have a nice simplified expression. Now I'm going to use direct substitution on the h. So if I plug in 0 here, I have 7 plus 0, so I'm going to get negative 7. So the instantaneous rate of change of that function at x equals 4 is negative 7, which is also saying the slope of the tangent line to that graph at x equals 4 is negative 7. Now I'm going to use the other method, and I should get the same answer because in theory they should both work. Okay, let's see where we're doing x equals 4. So let's do x approaches 4. See, f of x is the function as it is. Let me subtract f of 4. Let's see, f of 4 is 4 minus 16. And the denominator, I still have x minus 4. Okay, let's keep simplifying. I'm going to put it in standard form. So negative x squared, there's a positive x, and then this is a minus 12, which is a positive 12. Okay, over x minus 4. Now if I plug in 4 right now, I get 0 over 0, so it's indeterminate. I'm going to factor this. It looks like a factoring problem. But I feel like the numerator, this sign's off. Let me look at it. If I took out the negative, it would be x squared minus x minus 12. I'm going to factor it that way. So I'm going to keep the negative out. Then this is going to be x minus 4, x plus 3 over x minus 4. And then I can cancel out the x minus 4 factor. And I'm left with the negative and the x plus 3. Okay, now that it's simplified, I can go ahead and do direct substitution with the 4. So 4 plus 3 is 7. That's going to make this negative 7, which is the same answer I got previously. So both formulas should work and give you the same answer. Okay, for example, I'm going to identify the function, the x value, for the given instantaneous rate of change. So they're going to have you go backwards. They want you to look at how these people have plugged in to find the instantaneous rate of change. They want you to recognize which method they used or which formula, and then they want you to go back and figure out what the function was and at what x value they were trying to calculate the IROC. Okay, now let me look at this thing. Since h is approaching 0, and since it has an h at the bottom, it seems like they're using, what was that formula? The f of x plus h minus f of x1, which is not on my screen anymore. So it seems like it's this one, the x plus h minus f of x formula. So I'm just going to go back and try to figure out what the function was and then what they plugged in. So let me look at this. Okay, if I look at this, this has a 5, this has an ln, so does this. So that must be part of the function. Okay, now the bottom says 4 plus h. So it kind of seems like maybe the x is 4. I'm going to try it and see if it works. Okay, so if that's the x, then this would be 2 over x. Okay, let me look at this for a second. Now, if I plugged in, what did I think? And I'm thinking that the x value is 4, but I'm going to make sure. Okay, so if I want this to be x plus h, I would be plugging in 4 plus h. If I plug 4 plus h in here, it matches the equation. Now over here, this should be f of 4. So if I plug in 4 into this equation, I get 5 ln, let me do this on the side. I get 5 ln 2 over 4. Does that match? That does match that, because that's 5 ln 1/2. So this could be, this is the function that they used, and they were trying to calculate the instantaneous rate of change at x equals 4. Okay, I'm going to look at B now. Now, just looking at the denominator, it says x minus something. So they're using the other formula, the one that was f of x minus f of a over x minus a, or something like that. If that is the case, let me rewrite what I think they're doing. I think they're doing this. Okay, then I think that this should be pi over 2. So they're trying to calculate the instantaneous rate of change at pi over 2. Because also I can tell because x is approaching a, so this must be pi over 2. Okay, at the top, this should be f of x minus f of a. So it looks like f of x is sine x. I might want to double check that it works. If this is f of x is sine x, then this should be f of pi over 2. If I do sine of pi over 2, sine of pi over 2 is 1. So this works.